Welcome to my YouTube channel and the website Global Math Institute. Here is another video with IB student Aaria. We are going to discuss trigonometric identities related to compound angle formula. We have a set of questions based on related acute angle, correlated angle, trigonometric equations, and trigonometric identities. Hope you find good solutions for examination style questions in this video. You can master the strategies and succeed, and also develop critical thinking skills by joining my classes. Let us enjoy the journey of success and understand the concepts of trigonometry with the student Aaria. Hi Aaria, how are you doing?
Hi, no sir. How are you? I'm good.
I'm very good. So today, what do you want to do?
I have a few questions on a few things that I've been doing for trigonometric identities,
Mhm.
and some of them are on my paper here. So I thought we could maybe open up a whiteboard today, and you could write the questions down. We can solve them from there.
Sure, that is my pleasure. I'll do that. So here is a whiteboard. Tell me, what are the questions?
Okay, so the first question is, and I think we might have already done this, but I was just redoing it. Um, number use the double angle formula to verify that sine 2 pi over 3 equals to sine 8 pi over 3. For the double angle formula for sine 4x is what they want us to use.
Please read the question once again.
Use the double angle formula for sine 4x to verify that sine 2 pi over 3 equals sine 8 pi over 3.
So, double angle formula for sine 4x, and then we have to verify that sine 2 pi by 3 is sine 8 pi by 3. So, basically, sine 8 pi by 3 is 4 times this, right? So,
Yeah.
in a way, if you look at it, what they're saying is that
Is it just sine of
sine 8,
2 times?
8 pi by 3 basically
Right.
can be written as sine of 4 times, 2 pi by 3.
By
Does that make
3.
sense?
Right.
Let me write like this. So that is it, right? Now, but they are saying use the double angle formula to show that these two things are, 4, 2 pi by 3 is same, right?
Right.
Double angle formula for sine 4x. So let's use double angle formula for sine 4x and see what do we get, right? So sine 4x can be written as sine of 2 times 2x, correct?
Right.
So which is 2 sine 2x cos 2x, right?
Right.
So that is the double angle formula.
Oh, and then you have to expand. Basically, you have to go 2 sine theta is 2 sine x cos x times the derivation of cos 2x. So you can use either one. You can either use cos squared x minus sine squared x, and then I think you have to solve going from there based
Yeah,
on our
if
theta.
you correct. So if you compare this, let us say we compare this 4, 2 pi by 3, right? So
Mhm.
4, that means x is 2 pi by 3. Do you see that?
Right. So
So
can we
so we can
implement
now
that
write
on?
if x equals to 2 pi by 3, we can substitute x as 2 pi by 3. Is it okay?
Right. So we can go 2 sine
So now we get here,
2 pi by 3
yeah, so
cos.
let's write down here sine of 4, 2 pi by 3, right?
Right.
Is equal to what? So we can write this as 2 times sine 2x. So x is 2 pi by 3. So it becomes 4 pi by 3, correct?
Right.
And cos 4 pi by 3. Is it okay?
Mhm.
Now let's look into the special triangles. So when we are talking about pi by 3, that is the angle, right? Pi by 3. The sides are 1 to square root 3.
Right.
So sine 4 pi by 3 is what? Let's try to understand.
Would it just be two you could just use your compound angle formulas, right? To
No,
derive that?
4 pi by 3 means see. This pi is divided to 3 parts, and then 4 pi by 3 will be here, right?
Right.
So it is in quadrant 3 and it is negative. Similarly, cos 4 pi by 3 is also negative, right? Both are negative. Because if you apply the cast rule,
It's
you
a
know
double.
both are negative, right? Tan is positive in this quadrant, correct? So the acute angle here is what? Is pi by 3, right?
Right.
So we could write this as equal to 2 sine pi by 3
3
times
cos pi
cos
by 3.
pi by 3. Is that okay?
Right, right. Because we always use our related acutes in terms of when we're expressing.
Correct. And this really is sine 2 pi by 3.
Right.
Because if you go back, see, what is sine 2 pi by 3? Sine 2 times pi by 3, if I expand using a double angle formula,
Right.
it will mean 2 sine pi by 3
3 cos
cos
pi by
pi
3.
by 3. Do you see that?
Right,
So
yeah.
now you compare the two equations. This equation, let me call this equation 2 and this one as 1. Do you see that? You get
Right.
exactly same. So we started with 8 pi by 3. That is the right hand side.
Mm-hmm.
And we landed up with the left hand side, right? So which is basically, let me write here 2 pi by 3, which is the left hand side. Is that okay?
Yes.
So that is how you will actually show it. So you have to apply this double angle formula a couple of times
Mm-hmm.
and then get the result.
Right. This makes much more sense. Okay. The next question is use the appropriate compound angle formula and double angle formula to develop a formula for sine 3 theta in terms of cos theta and sine theta.
So basically, you need to find a formula for sine 3 theta, right? So
Right.
sine theta can be written as sine of 2 theta plus theta, correct?
Right. I got to that point.
Correct.
And then
Now we'll apply the formula. So sine 2 theta cos theta plus cos 2 theta sine theta, right? Now we know what sine 2 theta is. Sine 2 theta is 2 sine theta cos theta. And we already have cos theta here. Now we can break up cos 2 theta as, let's write in terms of sine. So cos 2 theta can be written as 1 minus 2 sine square theta times sine theta, correct?
Mm-hmm.
And let us expand this. We get 2 sine theta cos square theta plus we have sine theta times 1, which is sine theta, right?
Right.
And then minus 2 sine cube theta. So that could be the formula in which you know which formulas we have used. We have used sine A plus B,
Mm-hmm.
which is sine A cos B plus cos A sine B.
Right.
We have used sine 2A formula, which is 2 sine A cos A. We have used cos 2A formula, which is 1 minus 2 sine square A, correct? So we have these three formulas and got our result. And this is in terms of sine and cosine, right?
Right.
If you want, you can write it only in sine also. Your question said write in terms of sine and cosine, correct?
Yeah, it's a sine and cosine, so you could use both together. So
So
that's
both together. If it was only sine, note.
if you could simplify, right? Your
Yeah,
cos squared theta into 1 minus sine squared theta,
yeah.
and then
Then
go
you
for
have only sine.
only sine.
Correct.
And same thing, because like if you were to do this in terms of cosine, then you could just do 1 minus cosine squared if all these terms were cosine.
Yeah, yeah.
Right. This makes sense. We can move on.
Okay. Next question.
The next question, let me just check. Okay, it is the angle x lies in the interval pi. X has to be greater than or equal to pi over 2, but less than or equal to pi.
Okay.
And sine squared theta equals to 8 over 9. Determine the value of sine 2x, cos 2x, and cos x over 2. And also sine 3x.
And cos x over 2, half, right?
Half angle.
So you have to find all this.
Yes.
Okay, find all this. So you're given that x is between pi by 2 and pi. That means you are in quadrant 2, right?
Right.
So first thing that in quadrant 2, only sine is positive, right?
Right.
All others are negative. So sine square is given to us as 8 over 9.
I was thinking, could you take the square root plus or minus of 8 over 9, but we know the negative is an extraneous root, so you would just have sine theta positive square root of 8 over 9, which then we could take the inverse sine of and then find theta and then
No,
go from
right?
there.
Sine theta, don't find the angle.
Okay.
Then that is not the fun. The question really wants you to write without calculator.
Right.
So sine theta, when you do square root of 8 is 4 times 2, can be written as 2 square root 2, right?
Right.
Square
And
root of
3.
9 is 3.
So would that give us our opposite side length and our
Yeah.
hypotenuse, so then we could find our triangle
Correct.
using Pythagorean theorem?
Perfect. So theta is 2 square root 2 over 3.
Right.
Find this side. So adjacent side, let me write adjacent is equals to square root of 3 square, which is 9, minus
Minus.
2 square root 2 square, right?
Right.
Which is 8, right?
Right.
So this is 9 minus 8, which is 1. So this side
Right.
is correct.
Right. And so
So
from there, can we just find our primary trig ratios, like
yes.
cosine, and then you can use your double angle theorem to
Now
get
it's a
theorem?
question of using angles as substituting. Is that clear to you? So now sine 2x.
It's just a matter of substituting for the primary trigonometric ratios, just that.
Yeah.
Sine x, cos x. So we know what sine theta is and we know what cos theta is. So then you just substitute for that and you have your ratio.
Correct. But remember,
Right.
cosine will be negative. So you'll have a negative
Right. So it'd be negative 1/3.
negative 1. So that is a precaution you have to take. So you
Mhm.
get 4, but with a negative sign, square root of 2.
We can also figure that out, that cosine will be negative, just by looking at our restriction, right? Because we're in quadrant 2, so that cosine would just be negative from there. I think I can do, I think the rest of them are pretty
You can
stable.
do it because it's an application formula, and we have already derived the formula for sine 3x.
Sine 3x, right?
Use
Before.
that formula here, and you know double angle and half angle formula, so you can
Yeah.
find cos x by 2.
Sounds
Perfect.
good.
So
Perfect.
continue.
All right. So the next question is solve each question for the value of theta in the interval where theta has to be greater than or equal to 0, but less than or equal to 2 pi.
Okay, one full circle.
A, cos of 2x equals sine x. And then the second one being B, sine 2x minus 1 equals cos 2x.
Okay. So let's begin with the very first one. We are given sine cos of 2x.
Right.
So we'll do this cos of 2x equals to sine x. We should write this equation only in terms of one trigonometric ratio, right?
Right.
So you know that cos of 2x, let's write down the formulas, is equals to cos square x minus sine square x is also equals to 2 cos x, 2 cos square x minus 1 and 1 minus 2 sine square x, correct?
Right.
So in this equation, since we have sine there, we should write cos 2x as 1 minus 2 sine square x, correct?
Right. Correct. And then
Equals to sine x. Bring them all together.
So 2 sine squared x plus sine x
Right?
minus 1. Right. Right.
Now you can factor this. We are looking to split this into minus 2 is the product, right?
It's equal to 2 sine x.
Factor it.
Oh, I see.
And then you have sine x common. You get sine x plus 1. Minus is common.
Sine x plus 1 equals 0. And then 2 sine x plus 1 and then 2 sine x minus 1.
Equals
And so
to
then
0.
we know that one value of x will equal to negative 1. And then the second value will equal to half.
Correct.
But then
Now,
based on our
within
restriction,
this interval, tell me the answers.
based on that, we're doing a full circle, so I think it'll be negative 1, right?
So negative 1 means x is 3 pi by 2, right?
Pi by 2.
And for half, we are doing full circle, there will be two answers. Because sine wave, you remember, sine wave is like this, right?
Right.
So let me sketch this for the benefit of our students. So as far as negative 1 is concerned, we have only one value. As far as half is concerned, you can see there are two values, correct?
Correct.
And if you look into this special triangle, then you know sine is half for pi by 6, correct?
Pi by 6, right.
So pi by 6 and which? 1 less than pi minus pi by 6, right?
Yeah.
So that gives you two answers, x equals to pi by 6 and 5 pi by 6. You see that?
Right.
So that is how you can do part 1. Within this interval of 0 to 2 pi, we have these solutions, okay?
Right. And then I can do the same thing for the second one, expressing all of them in one term and then doing it from there.
Correct. So, yeah. So which one will you prefer?
I would probably do it in terms of sine. That just seems easier. But I might be wrong.
You could do. The only thing here is, see, you have this minus 1 here, right?
Right.
So that minus 1 can create some problems. So you have to be careful, but you can definitely do. So cos 2, see, sine 2x can be split only in terms of sine square x and sine x and cos x. It cannot give you only sine.
Right. So
And
maybe I would express everything in terms of cosine.
So let's try to do it, okay? Let me erase this. So question is what? Please tell me again.
So solve the equation for the values of theta in terms of the interval. Theta has to be greater than or equal to 0, but less than or equal to 2 pi. For b, sine 2x minus 1 equals to cos 2x.
So important thing to understand is that if you want to split sine 2x, it can only be written as 2 sine x cos x.
Right.
That is fixed. Now the thing is, how do we work with cos 2x? Here we have minus 1, right? So cos 2x, let's write this as cos square x minus sine square x for now. Now this minus 1 can be also written as sine square x plus cos square x. You see that? So what I'm trying to say here is that this minus 1 You also know that cos square x plus sine square x is 1, right?
Right.
Or you can say 1 minus sine square x is cos square x. We could
Right.
use this
Yeah.
1 in that fashion. You get the idea.
Yeah.
So think like this. We have 2 sin x cos x, and this minus could be written as sin square x plus cos square x.
Right.
And we have here, let's bring them all together. Minus cos square x plus sin square x equals to 0. Is that okay?
Yes.
Now here you see minus sin square x and plus sin square x will cancel.
Cancel. And cos squared x
Will double up.
will become minus 2 cos squared x.
So we have 2 sin x cos x minus 2 cos square x. Do you see that?
Yeah.
So we got rid of 1. So the problem was that because of that 1, we were not able to factor it.
Right.
So it is very important to split it as I did so that you could now factor. You know now cos x is common, right?
Mm-hmm.
So you can take 2 cos x common. And so you get sin x here minus cos x equals to 0. So that gives you 2 sets that cos x equals to 0. And here it gives you sin x minus cos x equals to 0, right? For cos x equals to 0, we have our solution that the wave is like this, right? And we know it is 0 at these 2 points.
Right.
And those answers, as you know, are x equals to pi by 2 and 3 pi by 2, correct?
Correct.
So here are those 2 answers. On the right hand side, we have sin x. We can take this on the other side. Think like this. Sin x equals to cos x.
That's what I was going to say.
And then divide by cos.
Right. To get your x.
So tan x is equal to 1.
Right.
So basically tan x is 1, and tan x is 1 for what? For x equals to pi by 4, right? So because tan is positive in these 2 quadrants.
Right.
So we have pi by 4 here, right? So 1 pi by 4, 2, 3, 4, 5 pi by, and 5 pi by. Do you see that? So we have answers or the solutions for this equation are pi by 2, 3 pi by 2, pi by 4, and 5 pi by 4. Is that clear to you?
My question is that from pi by 4, you derive 5 pi by 4. So are you just counting from where your related to Q is situated from that quadrant to where the value would be positive?
Easy counting. 1 pi by 4, 2 pi by 4. Do you see that?
Right.
3 pi by 4. 4 pi by 4 is pi, right? So
Right.
5 pi by 4. Easy counting.
Oh, so it's the
or you could do pi plus pi by 4, right?
Right.
Which is 4 plus 1 over 4 pi, right? 5 pi by 4.
So basically, you're trying to find the other reflected value, which would be in the quadrant of the primary trig ratio. Where,
yeah, where tan is positive, right? Because we have tan of positive, right?
Right.
So cos rule.
Oh yeah, because in the first and the third quadrant is where tan would be positive. If this was cosine, then we'd try to find it from where the first and the fourth quadrant, right?
Yes.
Okay, that makes sense.
Perfect. So that was tricky actually. So how to deal with minus 1. So make a note of this so that wherever it is there. So let me just get back to this one, many different ways. I'll again focus on Pythagorean theorem, which is, we have 3 of them, right?
Right.
So here, 1 plays a significant role, as you know. We have been writing sine square x as equals to 1 minus cos square x, and cos square x as 1 minus sine square x.
Right.
On the other hand, we have 1 plus tan square
X
equals to secant
squared x.
where x. Now here 1 is equal to difference between secant square x and tan square x.
And then you also have your cosecant and your cot.
Yes. But this can be written as product of sum and difference.
Right.
And therefore, we can write sum of secant x and tan x as 1 over difference of secant x and tan x.
Yeah.
Similarly, if we have 1 plus cotangent square x, this is cosecant square x. So here also 1 is equals to cosecant square x minus cotangent square x. So which is doing the same strategy. We can write this as a product of cosecant x theta plus cot x times cosecant x minus cot x. And therefore, I could also write cosecant x minus, let me write this time, as 1 over cosecant x plus cot x. Do you see that? So these relations also can be derived, and the value of 1 can be seen in so many different ways. It really helps
Right.
to figure out solutions, right?
Yes.
Clear?
Clear. Now we're gonna move on to, because we did all the questions that I had from that I had doubts on. Now that we're gonna move on to the trigonometric identity questions that I
Sure.
have. There were only a few because I was able to solve most of them.
Very good. You worked hard. You must have done 50 plus questions, right?
Yeah, I actually no. I listened to your advice and I tried to space it out. So I did 10 questions in the 2 days. Like I did 10 questions per day. So I still have to finish some of my questions, but the ones that I've done today, the first one that I had a question on
Yeah.
was and these are proving. So sine q theta plus cos q theta equals to sine theta plus cos theta in like a bracket. And then open another bracket, and then 1 minus sine theta cos theta.
Correct. So to do this type of equation, what we need to remember is the formula. What is a cube plus b cube equals
Right.
to? So a
A,
cube plus b cube is, yeah, tell me.
a plus b whole cube.
No, a plus b times a square minus ab plus b square.
Oh,
So that's the formula you should know.
okay.
And it's a very important formula. If it is a cube minus b cube, this becomes minus, that becomes plus. Okay. So make a note of this formula. Then the question will be very simple. You see, straightforward?
Yeah. Okay, that makes so much more sense.
Because for sine and cosine, a square plus b square is sine square theta plus cos square theta, which is 1. Do you see that?
One. Yeah.
The straight answer. You see
And
that?
then AB is just your sine theta cos theta. That's it.
Done, right?
And AB here is also sine theta cos theta. Okay, yeah. That makes sense. I just didn't know the formula.
Yeah. Good. So done
Okay.
with this. Next question, please.
Number 12 was secant theta plus 2 sine theta over cos theta plus sine theta equals to 1 plus tan theta.
So the left side is more complicated. We should
Yeah.
begin with left side, right?
Right.
We have both the terms sine and cosine. So if I use this secant as 1 over cos, then let us see what do we get, right?
Right.
That is one way of looking into it.
That's what I always try to do is I try to make them all into like sine and cosine ratios and then try to figure out if I can use Pythagorean identities anywhere because that seems like the most easiest way to like figure
Correct.
it out.
Correct. So let's try to figure this out in that fashion. So secant is 1 over cos. So I will write this as 1 over cos theta plus 2 sine theta over
Cos theta
plus
plus
sine.
sine theta. So
Now
then
when you multiply, then it becomes 1 plus, take common denominator, 2 sine theta cos theta, right?
right.
Cos theta multiplies the denominator, so you get cos square theta plus cos theta sin theta.
Oh, you already flipped them. You,
Yeah.
oh,
So
you already did them big division with the
yeah,
cos
so
theta.
you can think like this. Sometimes what I do is think like this. You multiply this thing by cos theta, right?
Mhm.
And also this thing by cos theta.
Right, so it removes the denominator automatically.
So yeah, so that way is cos theta when you multiply this cancels and you get 1, and here you get 2 sin theta cos. Does that make
Right,
sense?
I think my error came from when I had to like do the big division of the fractional division.
I see.
And so I think that's where I messed up because I have the top part is like as is. I just didn't get the cos squared theta. So I think that's where it went wrong.
Okay. Now tell me what will you do? Okay, tell me what will you do now?
From here, I know that this 2 sine theta cos theta basically equals to sine 2 theta. And my cos squared theta, I can write it as 1 minus sine squared theta.
No, but you want to prove 1 plus tan theta. So why will you convert to 2 theta? You should know.
Oh, you should know.
Yeah,
Okay.
because you check right hand side. Is it 1 plus tan theta, right? In your question?
Right.
Correct? So do not convert that. Right?
Okay.
Now look here. This is
Could I
all
factor
very,
out a cosine from the denominator?
that is a good step. So factor cos theta, which is as it was written. You see that? No need to expand it.
Yeah.
Now look at the numerator. Numerator is actually speaking cos theta plus sin theta whole square. Is it that or not? Tell me.
Cos theta sine theta whole
Whole
square.
square. Let me show you how. Very important. When you get this, one it can be written as cos square theta plus sin square theta, correct?
Right.
You got 2 sin theta cos.
Sine theta cos theta. Right,
So
because
the
cos
numerator
squared theta plus
is
sine squared theta equals 1.
cos theta plus sin theta whole square. Do you see how we used 1 very
Yeah.
effectively to simplify the
Um,
equation?
so whenever we have like 1 minus or 1 plus and we're stuck, you should always go into your Pythagorean identity and do cos squared
Yes.
theta plus sine squared theta. I see.
So now one of them cancels, right?
Right.
We are left with cos theta plus sin theta divided by cos theta. You see that?
Yeah,
Which is 1 plus tan theta.
exactly. Okay, there we go. See, that's where I was stuck.
So as you see, we need not even expand denominator. Now
No.
that is a strategy. Many times you do not have to expand denominator. Keep it in factored form. Factored form is better because you can cancel, right? So make this as one of your strategies. So strategy should be do not expand, and second, look at what you need. Do you see that? You
Right.
need 1 plus tan theta. That gives you a kind of a hint. We should not go for double angle or anything. Let's simplify towards tan theta, which is ratio of sine and cosine.
Right. This makes sense. Okay, I got it.
Yeah. Next question.
The next question is tan squared theta minus cotangent squared theta
Yes.
over sine squared theta minus cosine squared theta equals to secant squared theta times cosecant squared theta.
Correct. So you got all trigonometric identities right there on the screen,
Yeah.
right? So how should you use them? That is what we have to figure out.
I know that you have to use LHS because that has the most terms to work with.
Okay.
Um, I know that tan squared theta basically equals to sine squared theta over
1 plus
cosine.
secant square because we need secant and cosecant. So we will not convert this into this. Let's write this as
Oh, okay, I see. So I need to really look at my RHS based on that and then work through my
yeah.
solutions.
So I will write tan square theta as secant square theta minus 1. Do you understand?
Right.
And cotangent square theta is cosecant square
Cosecant squared theta
minus.
plus, oh, minus 1. Yes.
So we got that part, right?
Right.
That really doesn't help us much because that is the product form.
Yeah.
Anyway, one cancels, right?
Right.
One cancels. So anyway, we canceled one at least. So sine square theta minus, we could write this as sine theta times cos theta times cos theta sine
Yeah.
theta. We could factor this. We will keep it as such for now. Don't worry.
Okay.
So the numerator basically is minus 1 minus minus 1 cancels. So we have secant
Secant squared
square
theta
theta minus cosecant square
squared
theta.
theta.
And here we have, so secant is 1 over cos, and that is 1 over sine. So we do get a product
Right.
in the denominator. And
But couldn't we expand this based, so can we go secant theta minus cosecant theta and then secant theta plus cosecant theta, or is that not possible? And
you will
then
factor a plus b
yeah,
times b minus.
factor a plus, yeah, with that, and then do the same thing for the denominator, and then you can use your reciprocal trig ratios. So secant being 1 over cos, and then you can do from there.
Yeah, some will cancel, right?
Right. So I feel like that would be our best
Yeah,
way.
that could be. Yes, we could do that. So that is basically, then in that case, we could straight away convert this to sine and cosine.
That's why I was, yeah, that's what I was trying to say. Is like that's why I thought we should do that straight away
Okay,
from
so let's do that. So we'll convert this. We'll not go to this step. We'll go to what you're saying. We'll write this as sine square theta over cos square theta
yeah.
minus cos
Cos
square theta over sine
sine squared theta. And then all that over sine squared theta
Yeah.
minus cos squared theta.
Yes, yes.
But if you want to make the common denominators here, you could just do sine 4 theta.
No, don't go to 4.
Oh, okay.
Okay, we can factor it. Sine 4
Okay.
theta, yes, make common denominator.
Minus cos 4 theta.
So this product comes in the denominator. You can straight away write down here, right?
I know, sir, you wrote cos squared 4 theta.
Okay. Sine square theta minus cos
Cos
square.
squared theta.
Let me rewrite this. I wanted to write that product here. Realistic. So this product, which is
Sine
cos square theta sine square theta,
right.
comes in the denominator, right?
Right.
And gets multiplied with this, which is sine square theta minus cos square theta. Is it okay? Clear?
Clear.
Now the numerator will be split into difference of squares.
So sine squared theta plus cos squared theta, and then sine squared theta minus cos squared theta.
Yes.
And then you have sine squared theta minus cos squared theta, so that eliminates, and then you just are left with cos squared.
That is
theta.
what I wanted you to see. Perfect. So one you eliminated by cancelling, and the other one is 1. The other one is 1, right?
And so then the ratio is just sine squared theta over cos squared theta plus cos squared theta over sine squared theta. Oh yeah, it's 1. 1 over yeah. And so yeah, 1 over cos squared theta is secant squared theta times cosecant squared. That makes so much more sense.
Correct.
I don't know, would this be like a test type question or no?
Yeah, sure. All the questions which you have asked could be in the test paper. They are all very good questions.
Okay.
Yeah. So you got stuck at the right questions. Don't worry.
Okay. The next one is number 14, but I think it's similar to this one.
Then you
Most of
try. Tell me the question, you try.
I'll try it. Okay.